Hello, everyone. Today we are doing section 35, 1 and 2, which is translations, reflections, rotations, and dilations of objects or shapes, but we're going to use matrices in order to do all those. Okay, so remember, just a quick little review. Translation is just a slide or a glide. Reflection is a flip around a point or a line. Rotation, you're going to turn around a point, and then a dilation makes an object larger or smaller. Okay? So let's go ahead and look at example number 1. We have triangle ABC. It has vertices with these coordinates, A, B, and C, and we're going to find the coordinates after making the triangle 1.5 times larger. Okay? So looking at these, that would be a dilation because we're making the object larger. Okay? So how we write the coordinates of this triangle as a matrix, row 1 is going to represent the x values and row 2 is going to represent the y values. Okay, so and each column is each vertice. So point A is at negative 1, 1, so I'd write it like that. Point B is at 1, 4, and point C is at 5, 2. Okay, so that's how you would write the triangle as a matrix. Now we are asked to find the coordinates after we make the triangle 1.5 times larger. So that ends up just being a scalar multiplication problem. So we're going to multiply that matrix by 1.5. Okay, so we get the following. We get negative 1.5 because you're multiplying it just by each entry in the matrix, right? Okay, so negative 1.5, 1.5, 7.5, 1.5, 6, and 3. Okay? Just like that. That's a dilation. All right? Number 2, we have a quadrilateral with points A, B, C, and D. And we're going to write matrix T and simplify the matrix sum to represent the new coordinates of the quadrilateral after it's been translated 2 units left and up 4. Okay, so this is just sliding or gliding there. Okay, however you want to think of it. So let's first write the matrix, write matrix T and simplify the matrix. Okay, so we first need to write the matrix for the quadrilateral. So I've got negative 1, 1, 4, 0, 4, negative 5, and negative 1, negative 3. Okay, and the quadrilateral is moving 2 units to the left and up 4. How we represent that is we're going to add a matrix to this, and this means I need to move all of these x values 2 units left. So to show that, I'm going to be subtracting them all by 2. And there's a total of 4 coordinates since it's a quadrilateral, so I'm going to write that 4 times. Okay, and then it's also moving up 4. So that would be the y coordinates. All of those would move up 4. So I'm going to add 4 units to each of those entries as well. So that's how you would show that translation as a matrix. And remember, in order to add and subtract matrices, the dimensions have to be the same. So that's why this is laid out the way it is. All right, and then go ahead and literally just add all the entries together. Okay, so we get negative 3, 2, 2, negative 3, 5, 4, negative 1, and 1. And that's it. Okay. Now this says, how would the matrix of negative t translate the original rectangle? So this negative here, that just means like all of these are going to go opposite direction, right? So if I'm going left 2, up 4, the opposite of that would be right 2, down 4. Does that make sense there? You're just literally doing the opposite. Okay. All right. Let's keep it going. Now we're going to use the matrices below to reflect objects over the x axis, the y-axis, and the line y equals 0. So this says r subscript of x, so this is how you would reflect over the x-axis. This one would be over the y-axis, and this is the matrix you use if you're going to reflect over the line y equals x. Okay? So looking at number 4 here, we have triangle LMN, and it has the vertices listed here. We are going to find the new coordinates after it's reflected over the y-axis. That's what that means there, that notation. And then we're going to graph the pre-image, meaning that triangle, and then the final image as proof. Okay? So, first things first, we've talked about this already, but order matters when you're multiplying matrices. Okay? And that's exactly what we're going to do. So we are going to use this matrix right here because we're reflecting over y. So I've got -1, 0, 0, 1. And I'm going to multiply that by the matrix of triangle LMN. So -1, 2, -4, 1, -2, 5. Okay. All right, and we're going to do that on our calculator. So, second matrix. Oh, I should probably show that up there. I hit second matrix, okay? Go over to edit. Matrix A, I'm going to make the first matrix, so the 2 by 2, so -1, 0, 0, whoops, 1. Yep, we're good there. Second matrix. I'm going to make LMN matrix B. Okay, so 2 rows, 3 columns, so -1, -4, -2. Whoops. This is why you check. Okay, perfect. All right, so now I'm going to actually multiply those. So now I'm going to hit second matrix. I want A times second matrix B. And hopefully you guys got those same numbers. Okay, I have to move this over here because I'm left-handed. So I've got 1, 4, 2, 2, 1, 5. All right, so that means that their new coordinates, and I'm going to show this like that, okay? That's going to show the new coordinate, the translation. L, this was L. L has now moved to the coordinate 1, 2. M was at -4, 1. It is now at 4, 1. Whoops. There we go. And then N was originally at -2, 5. And it is now at 2, 5. Okay, so let's graph triangle LMN, and then we'll graph this triangle that's reflected over the y-axis and see if that actually worked out. So I've got 2. That's N, this was M, and this was L. So this is the original triangle. And then these are my new coordinates. So 1, 2 was L. 4, 1 was M. And 2, 5 was N. Which, that makes sense, because as you guys can see right here, that this triangle is definitely a reflection over the y-axis of that triangle. Okay? This is how you do that with a matrix. All right, let's flip it over. All right, now let's talk about rotations. Okay, rotation matrix. We've got R and then subscript of theta. This can be used to rotate a point in the coordinate plane clockwise amount of degrees about the origin. Okay, so this is the matrix that you would use here. I'm going to show you, we're going to write and simplify the rotation matrices for different angles here for 90 degrees, 180, and 270. You do not need to memorize them or technically like solve them because I'm just going to give you like what they are on a test or a quiz. But I do want to show you how they come about. So that's what we're doing here on number 5, okay? But you're going to take cosine of the angle in both of these entries and then sine of the angle in both of these entries. Just this one, you're going to do the negative version of it, okay? So let's talk about the setup here. So we've got cosine of 90, negative sine of 90, sine of 90, and cosine of 90. That's our setup. Okay. All right, unit circle. Let's think back. We should know this by now. Cosine 90 is 0. Sine of 90 is 1. Sine of 90 is 1. Multiply that by negative, you get negative 1. And we already said cosine of 90 was 0. So this is the rotation matrix if you're rotating by 90 degrees. Okay. Kind of like what we did over here with the reflections, same idea, it's just you just have a different matrix set up for rotations now, okay? All right, 180, so cosine of 180, negative sine of 180, sine of 180, cosine of 180. All right, let's think here. So that would be negative 1, that's 0, 0 times negative is 0, and that's negative 1 again. So this would be the rotation matrix if you're rotating 180 degrees. And 270. Set up that guy. All right, cosine of 270, that's 0. Sine 270 is negative 1. 2 negatives make a positive, and then we already said that's 0. Perfect. Okay. All right, again, these are going to be the rotation matrix. You do not need to memorize them. I will say the rotation for 90 is this. Rotation for 180 is that. You guys just have to know how to apply them and use them. Okay? So let's look at a problem that does that. So number 6, it says a triangle has vertices J, K, and L. Find the coordinates after the rotation of 90 degrees. So again, our order does matter. This will give us a 2 by 3 matrix. I do need to put the rotation matrix of 90 out in front then. So 0, 1, negative 1, 0, because order matters when you multiply matrices, right? We've discussed that. Yep, so I got this from up here, from what we found, okay? We're going to multiply that by J's coordinates were negative 6, 4, K was negative 3, 2, L was negative 1, negative 2. Just making sure I typed or wrote that all correctly. Okay, we're good. All right, so let's get after it. So second matrix, I'm going to go over to edit. This is already a 2 by 2. I just got to change these numbers. Negative 1, 0, 0, 1, negative 1, 0. Okay, second matrix, go over to edit. I'm going to make triangle JKL matrix B. Negative 6. Perfect. Okay. So now I'm just going to multiply those. So second matrix A times second matrix B, which gives me these coordinates here. Okay, check to make sure that's right. I'm going to move my calculator out of the screen. So I've got 4, 6, 2, 3, negative 2, 1. So that means that the new coordinates of J are 4, 6, K is 2, 3, and L is negative 2, 1. Those would be your new coordinates after a 90-degree rotation. All right, go ahead, start the homework, and let us know if you have any questions.